Welcome to Simultaneous Equations Level 6. Pause the video now, have a go at the 3 problems on the screen, and I'll go through them with you shortly. You'll find more practice at this level, plus links to the higher levels, as well as other topics, at the end of this video and on the channel homepage. In problem 1, we're solving x squared plus y squared equals 20 and 3x equals 2 minus y. Now, since we have a nonlinear and a linear equation here, we can solve these by using substitution. And to substitute, we need the linear equation to be written with either x or y as the subject, and at the moment it's not. So starting with that linear equation, we have 3x is equal to 2 minus y. Now we could divide both sides by 3 to make x a subject, but this would give us a fraction. So it's going to be a bit easier to make y the subject here. So I'm going to start by making the y positive by adding y to both sides. And on the left hand side, we have 3x plus y. And on the right, the minus y and the plus y cancel out to leave us with 2. We can now remove the 3x from the left by subtracting 3x from the left and doing the same on the right. And on the left, the 3x and the minus 3x cancel out to leave us with y. And on the right, 2 minus 3x is just 2 minus 3x. So we now have y as a subject. And so we know that y is equal to 2 minus 3x. So that means in the first equation, the nonlinear one, wherever we have a y, we can now substitute it with 2 minus 3x. So that first equation, x squared plus y squared is equal to 20, now becomes x squared plus, and in place of y, we're going to have 2 minus 3x in brackets squared is equal to 20. And our equation is now written entirely in terms of x. So we can expand, simplify, and hopefully solve this equation. So we have x squared plus, and to expand this squared bracket, we're just going to write it out twice. So we have 2 minus 3x multiplied by itself, and that's equal to 20. So we have x squared plus, and expanding these brackets, we have 2 times 2, which is 4, 2 times minus 3x, which is minus 6x, minus 3x times 2, which is minus 6x again, and minus 3x times minus 3x is plus 9x squared, and that's equal to 20. We can now simplify the left-hand side by collecting together the like terms. So we have an x squared and a plus 9x squared, which gives us 10x squared. We have a minus 6x and a minus 6x, so that's minus 12x. We still have plus 4, and that's equal to 20. Now, since this equation is quadratic, we'd like one side to be equal to 0. And we can achieve this by subtracting the 20 from the right-hand side and making sure we do the same on the left. And on the left, we now have 10x squared minus 12x, and 4 take away 20 is minus 16, and that's equal to 0. Now we notice here that the number in front of the x squared is not 1. And although we can divide every term here by 2, we're still not going to be able to get a 1x squared at the beginning. And so this means that although we might be able to factorise this, it might be easiest to just use the quadratic formula. Now before using this formula, we need to work out the values of a, b and c. And looking at the equation, a is the number in front of the x squared, which is 10, b is the number in front of the x, which is minus 12, and c is the constant at the end that's on its own, which is minus 16. So the quadratic formula becomes x is equal to, and on the numerator we have minus b, but since b is minus 12, this is minus minus 12, which is just 12, plus minus the square root of b squared, and again, because b is negative, we have to make sure this goes in brackets when we square it, minus 4 times a, which is 10, times c, which is minus 16. At the bottom we have 2a, so that's 2 times 10. And if we calculate this using a plus on the numerator, we get x equals 2, which is our first solution. And if we do the same using a minus on the numerator, we get x is equal to minus 4/5 or minus 0.8. So these are the first parts of our solution. What we now need to do is find a corresponding value of y for each of those values of x. And to do this, we can use our rearranged equation, y is equal to 2 minus 3x, because y is already the subject, and substitute these in. So starting with when x is equal to 2, this equation becomes y is equal to 2 minus 3 times 2. So 3 times 2 is 6, and 2 minus 6 gives us minus 4. So y is equal to minus 4, and these form our first pair. We can now look at what happens when x is equal to minus 4/5. So again, substituting it into y equals 2 minus 3x, we get y is equal to 2 minus 3 times minus 4/5. And this gives us y as 22 over 5. And these form our second pair. So our final solution to problem 1 is x equals 2, y equals minus 4, and x equals minus 4/5, y is equal to 22 over 5. In problem 2, we're solving 2x squared minus y squared equals 14 and 3x plus 2y equals 3. Now, since we have a nonlinear and a linear equation here, we're going to use substitution again. And we need to rewrite the linear, the second equation, either with x or y as the subject. And whichever way we do this, it's going to be a little bit messy and we're going to end up with a fraction. So starting with 3x plus 2y is equal to 3, I'm going to make y the subject just because dividing by 2 is going to be a little bit nicer than dividing by 3. So first I'm going to remove the 3x from the left, and I can do the same on the right. So on the left we're just left with 2y, and on the right we have 3 minus 3x. To remove the 2 from in front of the y, we can now divide both sides by 2, and this gives us y is equal to 3 minus 3x all over 2. And we've made y the subject. And the reason that this is useful is that now that we know that y is equal to this fraction, in the first equation we can rewrite y as 3 minus 3x over 2. So the first equation, 2x squared minus y squared is equal to 14, becomes 2x squared minus, and then in brackets we have 3 minus 3x over 2 squared, and that's equal to 14. And we now have an equation that's just completely in terms of x. To try and simplify this, I'm first going to look at the bracket that's being squared. And when you square a fraction, it's the same as squaring the numerator and the denominator separately. So we have 2x squared minus, and in this fraction, I'm going to square the numerator, so 3 minus 3x, all squared, and also square the denominator. And 2 squared just gives us 4, and that's equal to 14. I'm now going to try and expand the brackets to the top of the fraction. So we have 2x squared minus, and at the top of the fraction, the bracket is being squared, which means it's being multiplied by itself. So I'm going to write this as 3 minus 3x multiplied by 3 minus 3x over 4 is equal to 14. Continuing from here, we have 2x squared minus, and at the top of that fraction, we can multiply 3 by 3 to give us 9. And then 3 multiplied by minus 3x is minus 9x. Minus 3x times 3 gives us another minus 9x. And minus 3x multiplied by minus 3x gives us plus 9x squared. It's still being divided by 4, and it's still equal to 14. I can now remove the divide by 4 at the bottom of that fraction, and I can do this by multiplying everything by 4. Now I have to be really careful when I do this because of this minus in front of the fraction. So I'm going to think of this minus as being a minus 1 that's multiplying the whole of this fraction. So starting with the 2x squared, we're going to multiply that by 4, and that gives us 8x squared. We then have a minus 1 times, and when we multiply the fraction by 4, the denominator just disappears. So we have 9 minus 9x minus 9x plus 9x squared. And that's equal to, and we need to remember to multiply the 14 by 4, which gives us 56. We can now expand the final bracket on the left-hand side. So we have 8x squared, and every term in this bracket is going to be multiplied by minus 1. And the effect that has is it just changes its sign. So the positive 9 becomes a negative 9. The negative 9x's both become positive 9x's, and the positive 9x squared becomes a negative 9x squared, and that's equal to 56. On the left, we can now collect together the like terms. So we have 8x squared minus 9x squared is minus 1x squared, or minus x squared. The plus 9x and the plus 9x make plus 18x, and we still have a minus 9 there, and that's equal to 56. Now to solve a quadratic, we want it to be equal to 0. So we're going to make the right-hand side 0 by subtracting 56, and we're going to do exactly the same on the left. So the left becomes minus x squared plus 18x, and minus 9 minus 56 gives us minus 65, and that's equal to 0 because 56 minus 56 gives us 0. Now it often helps to have our x squared term as positive, and so to do this I'm just going to multiply everything in the equation by -1. So we have x squared minus 18x plus 65 is equal to, and 0 times -1 is just 0. Now since we have a single x squared at the start of this equation, we can try and factorise this. And to factorise it, we need to find two numbers that multiply to make 65 and add to make -18. And two numbers do exist, they're quite tricky to find. They are -13 and -5. Because -13 multiplied by -5 is 65, and -13 plus -5 is -18. If you couldn't find those numbers, you could just use a quadratic formula or even complete the square and solve it. But since we have those two numbers, we can factorise. So we're going to have two brackets. We're going to have an x at the start of each one because x times x gives us x squared. And our two numbers, -13 and -5, go at the end of those brackets. And this is equal to 0. So we now have two brackets being multiplied together to make 0. And the only way that that can happen is if the first bracket is 0, so x minus 13 is 0, or the second bracket, x minus 5, is equal to 0. So we can now solve these equations independently. For the first equation, x minus 13 is 0, we can add 13 to both sides, and we get x is equal to 13. And similarly, for x minus 5 equals 0, we can add 5 to both sides, and we get x is equal to 5. So these form the first part of our solution. We now need to find a corresponding value of y for each of those x values. And to do this, we're going to use a rearranged equation, y is equal to 3 minus 3x over 2, because this has y as a subject. So if we start with when x is equal to 13, this becomes y is equal to 3 minus 3 times 13, all divided by 2. And this gives us y as minus 18. So these form our first pair. We now take x is equal to 5 and do the same thing. So substituting in gives us y is equal to 3 minus 3 times 5, all divided by 2. And this gives us y is equal to minus 6. So we have our second pair. And so our final solution to problem 2 is x equals 13, y equals minus 18, and x equals 5, y equals minus 6. In problem 3, we're asked to find the coordinates of the points where the lines with equations y minus 2x equals 1 and y squared plus xy equals 7 meet. Now, if we're asked to find coordinates where two lines meet, what we need to do is solve the equations simultaneously and write our solutions as coordinates. And for these equations, we have a linear and a non-linear equation, and so we need to solve these by substitution, and we'd like to have the linear with either x or y as a subject. So starting with the linear equation, y minus 2x equals 1, we can make y the subject very quickly by adding 2x to the left and doing the same on the right. And this equation becomes y is equal to 2x plus 1, or 1 plus 2x. And now we have y as a subject, we know that we can take 2x plus 1 and substitute it in place of y in the non-linear equation. So the equation y squared plus xy is equal to 7 becomes, in brackets, 2x plus 1, because we're substituting y for 2x plus 1 squared, plus x multiplied by, and again we're going to replace the y with 2x plus 1, is equal to 7. And this equation is now completely in terms of x. We can expand, simplify and solve. So the first bracket that's being squared we can rewrite as 2x plus 1 multiplied by itself. We can expand the other bracket straight away, so x times 2x gives us plus 2x squared, and x times 1 is plus x, and that's equal to 7, and we can now expand the two brackets at the start. So 2x times 2x gives us 4x squared, 2x times 1 is plus 2x, 1 times 2x is plus 2x, and 1 times 1 is plus 1. And we still have a plus 2x squared, a plus x, and that's equal to 7. We can now simplify the left-hand side by collecting together the like terms. So we have a 4x squared and a plus 2x squared. This gives us 6x squared. We have plus 2x, which is plus 4x, plus another x is plus 5x. And we still have a plus 1 on that side, and it's equal to 7. Now, since we have a quadratic, we'd like to make it equal to 0. And we can do this by subtracting 7 from the right and doing the same on the left. And on the left we have 6x squared plus 5x, and 1 minus 7 is minus 6, and that's equal to 0. Now we have a number in front of the x squared that's not 1. So this tends to be more difficult to factorise, and so I'm going to use a quadratic formula, but you can solve equations like these by factorising as well. So we need to establish our values of a, b and c. Well, a is the number in front of the x squared, which is 6, b is the number in front of the x, which is 5, and c is the constant at the end that's on its own, which is minus 6. So our equation becomes x is equal to, and on the numerator we have minus b, so that's minus 5, plus or minus the square root of b squared, so 5 squared, minus 4 times a, so times 6, times c, which is minus 6, all divided by 2a, which is 2 times 6. And if we calculate this with a plus on the numerator, we get x is equal to 2/3. And if we calculate it again but using a minus on the numerator, we get x is equal to minus 3/2. So these are the first parts of our solution. We now need to find a corresponding value of y for each of those values of x. And we're going to use the equation y equals 2x plus 1 that we rearranged earlier because we have y as a subject here. So starting with x is equal to 2/3, if we substitute this into this equation, we get y is equal to 2 times 2/3 plus 1. And 2 times 2/3 plus 1 gives us 7/3 or 7/3. So these form our first pair. Similarly, if we take our second x value minus 3/2 and we substitute it into y equals 2x plus 1, we get y is equal to 2 multiplied by minus 3/2 plus 1. And this gives us y is equal to minus 2. And this is our second pair. So we know that these two lines meet at two different places. And so we can say that they meet at the points which have coordinates. Well, the first point has x coordinate 2/3 and y coordinates 7/3. And the second point has x coordinate minus 3/2 and y coordinate minus 2. So these are the 2 points where the lines meet.